Hello students, welcome to Shri classes. Let us start the new chapter number 2, Polynomials. Chapter flow goes like this: Introduction to polynomials, types of polynomials, zeros, roots of a polynomial, geometrical interpretation of zeros and roots of a polynomial, relationship between zeros and coefficients. For quadratic and cubic we are studying in detail, and most of the numericals involves part number 5. And finally, the division algorithm in polynomials, which is also one of the important things. So all these from here to here, these are the basics which I have studied in 9th standard also, but once again we'll revise. And 5th and 6th are most important concepts of the chapters, and a lot of numericals are involved based on 5th and 6th concept. Okay, so let us begin with the introduction to polynomials. You can note down the chapter flow also. So introduction to polynomials. See, generally polynomials are represented by P of x, f of x, g of x, f of t. These are the general notations that we use. What is the meaning of this one here? Polynomial in variable x. This is a polynomial in variable x. This is a polynomial in variable x. Whereas f of t here, this is a polynomial in variable t here. Is it clear? Now let us define what is polynomial. Definition of a polynomial we'll see. How to define the polynomial? An expression, an algebraic expression P of x of the form, an algebraic expression P of x, this is P of x here, P of x of the form P of x equals a0 a1x plus a2x square plus a3x cube plus dot 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 plus I can consider a n minus 1 into x to the power n minus 1, and finally a n x to the power n. Finally I can write the last term itself, a n into x to the power n. So this is called a polynomial. So an algebraic expression P of x of the form P of x equals this is called a polynomial in variable x of degree n here, of degree n here. This is called a polynomial in variable x of degree n. Important here, a to the power n should not be equal to 0. a0, a1, a2, a3 dot 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 up to an. These are called real numbers. These are all real numbers and nothing but coefficients of x here, and one of them will be a constant. For example, a naught will be a constant, rest of all are coefficients of x, x square, x cube, etc. Okay, a0, a1, and also important is here n, it is a non-negative integer. And this is called exponent, which is nothing but the power. So it should be a non-negative integer. The meaning of non-negative integer here, it is whole numbers. Whole numbers. So this is called a polynomial. You must remember, a polynomial is an algebraic expression in the form of this a0, a1 to the a1 into x, a2 x square, a3 x cube. It continues, and these are the conditions. Note it down first. Let us look at some examples here. Examples of polynomials, which are polynomials and which are not polynomials also. Couple of examples we'll see here. Example, p of x equals 2x plus 5. This is a linear polynomial. F of x equals root 2x square plus 3x minus 8. F of t equals t square by 4 minus 5 by 8. All these are polynomials. And one more couple of examples I'll take which are not polynomials. P of x equals 1 by x plus 8. This is not a polynomial. Also, let me take one more example. P of y 8 by y square minus 4y plus 9. You understood? Here, these are the examples of polynomials, and not this one, up to here. Okay, and these two are not polynomials. These are not polynomials. Reason, y to the power minus 2, it is a negative integer. If the exponent becomes negative, then it is not a polynomial. Here also x to the power minus 1, and the exponent becomes here negative, and therefore these two are not polynomials. Rest of all are polynomials. Here it is root 2 times x square. If the root is involved, for example, this is also not a polynomial. Example, say for example, p of x equals root of x, or I'll write like this, x square plus under root of x minus 6. This is also not a polynomial, because here this is nothing but x square plus x to the power half minus 6, isn't it? But actually we are talking about integers, whereas here it is a fraction, and therefore this is also not a polynomial. These are few examples for polynomials and not the polynomials. You can note it down. Next, second concept, we'll go to the types of polynomials. Second concept, types of polynomials and their general forms. And general forms. General forms are also called standard forms. Okay. So types of polynomials. In this one, first one, linear polynomial. A polynomial of degree 1, a polynomial of degree 1 is called a linear polynomial. A polynomial of degree 1 is called a linear polynomial. General form, p of x equals ax plus b, where a should not be equal to 0. If a becomes 0, this will not be a linear polynomial, but it will be different, which we will be studying. So condition will be a should not be equal to 0 here. So here what is the degree here? Actually we should understand the degree also. What is the meaning of degree? That you have studied in 9th standard, therefore I am not explaining here. Here highest power of variable is called the degree, isn't it? What is the degree basically? Highest power of a variable is called a degree. Here variable is x, its power is 1. If the degree is 1, it is called a linear polynomial. For another couple of examples I'll give you here. P of x is equal to 5x to the power 4, 5x to the power 4 plus 8. What is the degree over here? Variable is x and iska power hai 4 hai, and therefore this is called the degree 4, isn't it? Highest power of the variable is called the degree here. I hope you know that already. All of you know what is the degree of a polynomial. Okay, next, linear polynomial of degree 1. General form is 1. This is the general form. What else is to be written? Let me check for this. Examples will give. Couple of examples. P of x equals 5x plus 8. Another example, f of t equals, for example, t minus 8 by 5. These are two examples which are enough. Second one. Here minus 8 by 5, it is a constant here. The constant can be anything, whereas t should not be under root and t's power should be integers. And which kind of integers? Whole numbers basically. Then only it will be polynomial. So these are the two examples. Second one, let's go for quadratic polynomial. Quadratic polynomial. Okay. How do you define a quadratic polynomial? A polynomial of degree 2. A polynomial of degree 2. A polynomial of degree 2 is called a quadratic polynomial. Is called a quadratic polynomial. A polynomial of degree 2 is called a quadratic polynomial. So a quadratic polynomial is of degree 2. General form. P of x equals ax square plus bx plus c, where a should not be equal to 0. Here ax square, bx and c, these are the three terms here. A is the coefficient of x square, b is the coefficient of x and c is a constant term. Here the general form is P of x equals ax square plus bx plus c, where a should not be equal to 0. Remember, ax square, bx and c, these are the three terms over here. A is the coefficient of x square, b is coefficient of x and c is the constant term. Examples let us take now. P of x equals 3x square plus 2x plus 8. Very simple example. P of x equals, another example we will take it, x square minus 5 by 8x plus 3. Any other examples? You have already seen all quadratic equations. The left side of the LHS of the quadratic equation is nothing but a quadratic polynomial. You are very familiar with all this. So we have taken linear polynomial, quadratic polynomial. These are the general forms, and these are couple of examples. Let me check if any typical example. Yeah, one more typical example I'll take here. P of y equals minus y square plus 2 root 2y minus 8. Here 2 root 2 is a constant, coefficient basically, coefficient of y, and hence it's a polynomial. So these are the few examples here. So let's go to the next third one. Note it down. You can pause the video to note down, okay? Third one, cubic polynomial. Cubic polynomial. A polynomial of degree 3 is called a cubic polynomial. A polynomial of degree 3 is called a cubic polynomial. General form: P of x equals ax cube plus bx square plus cx plus d. Examples: P of x equals minus 3x cube plus 3x square minus 4x plus 8. Another example I'll take: f of x equals 4 root 2 x cube minus 6. These are few examples for cubic polynomial. Here, what is the degree here? Highest power of the variable is 3 here. If you compare all this, this is 1, 2, 3, highest power is 3, hence it is a cubic polynomial. And here once again, this one and this one, this one, this one, all these are terms of the polynomial. There are 4 terms here. 3 is a coefficient of x cube, 3 is a coefficient of x square, minus 4 is the coefficient of x, and 8 is called the constant term. So you should also understand the terms and the respective coefficients along with the constant term here. Next, fourth one, cubic polynomial, biquadratic polynomial. Biquadratic polynomial. So how do you define this one? If the degree of a polynomial is 4, it is called biquadratic polynomial. A polynomial of degree 4 is called a biquadratic polynomial. General form: is P of x equals ax to the power 4 plus bx cube plus cx square plus dx plus e. One example I'll take here: P of x equals 4x to the power 4 minus 8. That's all. Rest of the terms, forget it. Whether those are present or not, we need not bother about that. What is the variable here? X. What is the highest power? 4. Hence it is called a biquadratic polynomial. One more example in the form of a general form. Let us take it. It is minus 4x to the power 4 plus 3x cube minus 2x square plus 8x minus 9. So this is one more polynomial. So 4 types are over. You note it down. Let me clear the board. Fifth one, it is called constant polynomial. Constant polynomial. A polynomial of degree 0 is called a constant polynomial. A polynomial of degree 0 is called a constant polynomial. General form: P of x equals to, we need to have a constant over here, then only it is called a constant polynomial of degree 0 here. So I'll write P of x is equal to 9, or I'll say something like P of x is equal to, say for example, a here, where a is a constant, where a equals constant. which belongs to any real number. Basically it can be any real number. 8.2 also it's a constant. P of x is equal to this. Why this is called a constant polynomial? How the degree is 0 over here? You may be wondering why the degree is 0 here. I can write like this: ax to the power 0, ax to the power 0, x to the power 0 is 1, which is p of x equals a here, and therefore the degree will be 0. Okay, note it down. And which are the examples? Some examples you take it. F of x equals 8. This is the example. Next one, sixth one, 0 polynomial. Okay, here f of x equals 0 is called a 0 polynomial. Zero polynomial. What is the degree of this one? The degree is not defined. Degree of a 0 polynomial not defined. Why not defined? You take any example over here. For example, why not defined? Here I write y. See here, f of x equals 0 into x to the power 2. F of x equals 0 into x to the power cube. F of x equals 0 into x to the power 112. So all these are 0 polynomials. Multiplied with 0, everywhere you get 0. What about the degree here? Can you say here the degree is 2, degree is 3, degree is 112? Never possible, because ultimately you end up with 0, isn't it? And therefore degree of the 0 polynomial, it is not possible to ascertain it. Here can you say 2, 3 or 112? Not possible, no? Hence the degree of the 0 polynomial is not defined. Okay, note down, we have discussed so far the different types of polynomials. Okay, please note it down. Third concept now, zeros are roots of a polynomial. Roots of polynomials. So what is the root of a polynomial? So how do you define? For example, actually what exactly is the 0 is here, that value of the variable, if substituted in a given polynomial, the given polynomial's value reduces to 0. Are you able to understand? Say for example, some polynomial is given to you, something like x square plus 2x plus 3, x square plus 2x plus 3. You put that value of x, if substituted into the same polynomial, and if the value of the polynomial becomes 0, then that value of x is called the 0 of a polynomial. So how do you define 0 of a polynomial here? Let's see here. A real number alpha is called a 0 or root of a polynomial, p of x if p of alpha equals 0 here. Is it very clear? That alpha is called the root. If I substitute alpha in x, then the p of alpha becomes 0, isn't it? So this is called the 0 or root. Both names, see here, you must understand 0 as well as root, both are same here. Okay, so a real number alpha is called the 0 or a root of a polynomial if p of x of a polynomial p of x if p of alpha is equal to 0. That means that value of the variable, if substituted in a given equation, if the polynomial reduces to 0, then that value of x is called the root of a polynomial. So let us take one example here. Check whether 3 minus 1 1 are the roots of the given polynomial. Example I will take here. Example, check whether 3 minus 1 and 1 are roots of 3 P of x equals x square minus 2x minus 3. X square minus 2x minus 3. So which are the roots over here? Let us substitute values over here and check whether these are the roots or not, isn't it? Okay, now first let us check the 3, minus 1 and 1. Let x equals plus 3 here, first one. So we know P of x equals x square minus 2x minus 3. Check for P of 3 here. P of 3 equals 3 square minus 2 times 3 minus 3, which is 9 minus 6 minus 3, which is 9 minus 9, which is 0, isn't it? So if the value of x is substituted as 3, then the given polynomial reduces to 0. Hence x equals 3 is called the root of a polynomial, or 3 is called the root of a polynomial. Therefore 3 is a root of P of x. Let us check the next one. Let x equals minus 1. P of x equals x square minus 2x plus minus 3 here, minus 3. Let us substitute minus 1. When I put x equals minus 1, then I write p into bracket minus 1. What is the meaning of p into bracket minus 1 here? Meaning I am substituting the value of x as minus 1. Remember, whenever we write p of some number, here we should not see any variable, but in place of the variable, this number is to be substituted. That should be kept in mind. So which equals minus 1 square minus 2 times minus 1 minus 3, which equals minus 1 square is 1 plus 2 minus 3, which is 3 minus 3, which equals 0. And therefore minus 1 is a 0. Minus 1 is a 0 of P of x. Let us check the next one. Let x equals 1. P of x equals, what is the equation? Let me write once again, x square minus 2x minus 3. So P of 1 equals 1 the whole square minus 2 times 1 minus 3, 1 minus 2 minus 3, which equals 1 minus 5, which is minus 4, isn't it? And therefore, as the polynomial has not reduced to 0, 1 is not the root of a polynomial. Here 1 is not a root of P of x. I hope you have understood how to check the given numbers, whether these are the roots of a given polynomial or not. Note it down. Let us look at the fourth concept now. Geometrical meaning of zeros, which are also called roots of a polynomial. What is the geometrical meaning of roots of a polynomial? So I am going by one by one: linear polynomial, quadratic polynomial, cubic polynomial. And what do you mean by geometrical meaning? In general, I am talking about the meaning of geometrical, or the geometrical interpretation of the roots is something like this. The x coordinate of point of intersection of the graph with x-axis is called the zero of a polynomial. What is zero of a polynomial or a root of a polynomial? Basically, the y coordinate should become 0, isn't it? If I plot a graph of y is equal to f of x, then y will become 0 there, isn't it? The value of the polynomial becomes 0. So that value of x, where the polynomial reduces to 0, is called the root of the given polynomial which you have studied. So geometrically I can put like this: the point of the x coordinate of the point of intersection of the graph with x-axis. X coordinate of the point of intersection of the graph with x-axis is called the zero or root. Let's see now. First one, linear polynomial. Linear polynomial, general form: P of x is equal to ax plus B. Okay, so here the graph of y equals p of x implies y equals ax plus b is basically a straight line, because it's a linear polynomial and the graph must be straight line. Okay, so let us draw the graph over here like this, and suppose this is the given polynomial. This is the graph of a given polynomial, x dash, y dash, and what is the equation? Y equals ax plus b over here. Remember, a should not be 0 here, important. Y is equal to ax plus b. This is the equation of this straight line. The point of intersection of the straight line with x-axis lies here, isn't it? Suppose the value of this is k comma 0. What are the coordinates of this point? K comma 0. X coordinate is k and y coordinate is 0 here, and therefore the root is x coordinate of the point of intersection of the graph with x-axis. Therefore here 0, or the root is k here. Is it very clear? Here this is the point of intersection. This is the point of intersection of the given graph with x-axis. X coordinate of the point of intersection is k over here, and therefore the 0 or root is k. Okay, so note it down. Then we will go to the second one, quadratic polynomial. See, before we go to the next one, let me explain another couple of graphs over here, because last time somebody had asked, some of the students had asked, what is the graph of y is equal to 5, x is equal to 5? You are not able to plot that graph, but you have already studied in 9th standard in detail, actually speaking. Say for example, let me draw a couple of graphs and try to find out the roots of that one, 0 of that one. Okay, fine. So let us take for example one graph like this. This is p of x equals ax plus b. Suppose this point here is 3 comma 0. So what is the root in this case now? I hope already you must have guessed it. The root or 0 is here. 0 or root equals 3 here. Isn't it? 3. Generally for a linear polynomial we represent it by k. K is the root. Like for quadratic polynomial, alpha and beta are the roots, and for cubic polynomial, alpha, beta, gamma, already you know these things, and therefore generally the root of a linear polynomial is represented by k. Hence I will say root k equals 3 here. I can say like this. Let me take another graph now. First graph is something like this. Second graph. Y dash, x dash, here also we will see. Now here what is the graph, I'll give the coordinate over here. What is the coordinate of this point? Basically the coordinate of this point here is 0 comma 5. Okay, what is the equation of this graph? By the coordinate, by looking at this itself, I can conclude that y is equal to 5 here. See here, this is 5 units. So y equals 5 is the graph. What is the graph here? The equation of the graph is nothing but a straight line here. What is the equation of this graph? Equation of this graph is y equals 5. What is the root over here? Is it intersecting with or is it cutting the x-axis? It is not cutting the x-axis, and therefore no roots exist. No roots. No roots or no zeros, because it is not cutting the x-axis. What is the root? Basically, if the graph, the x coordinate of the point of intersection of the graph with x-axis means wherever the graph cuts the x-axis, x coordinate of that point of intersection is called the root. One more example I'll take here. Third one. Here this is x equals 4. So can you guess what is the root there? X equals 4 means this point of intersection here is nothing but from here to here, this is 4 units. Meaning, what are the coordinates of this one? First is x coordinate, next y coordinate, 4 comma 0, and hence root here, root equals 4 here. Is it clear? So with the 3 examples we have demonstrated what is the root. That means I can say if the linear polynomial is there of degree 1, then how many maximum number of roots you can find out? Maximum number of roots will be equal to the degree of a given polynomial, and here degree is 1, hence maximum you can have only 1 0 or 1 root. Can we have 0 roots? Yes, check here, no roots exist here. Maximum only 1 root, meaning the graph, if it is parallel to x-axis, it will not intersect. All other graphs non-parallel to x-axis must definitely intersect with x-axis, and hence those lines must intersect x-axis, cut x-axis, and at least 1 root should be there for that. So you can note down these examples also, because some of you were asking me the graphs of y equals constant, x equals constant. Note it down. Now let us look at geometrical interpretation of the zeros or roots for a quadratic polynomial. Second one. Quadratic polynomial. See, what is the general form? P of x equals ax square plus bx plus c. What is the degree here? Degree is 2. Therefore, maximum number of roots equal to degree. Maximum number of roots equal to degree, meaning 2 roots. How many zeros you can have for a quadratic equation? Maximum number 2. Can we have 0 roots? Yes, possible. We will see graphically. Now, the graphs of this quadratic equation is called a parabola. Parabola is represented in 2 ways, which is called the upward parabola or upward opening parabola, and downward parabola or downward opening parabola. Okay. So let us see the graph of quadratic equations will be y equals p of x implies y equals ax square plus bx plus c. What is the graph of this one? The graph will be something like this. These are called parabola. Such graphs are called parabola. Name of this one is parabola. What is the equation here? Y equals ax square plus bx plus c. And this is called upward opening parabola. Upward P-A-R-A-B-O-L-A. Upward opening parabola. When this upward opening parabola, when do you get it? See, coefficient of x square, if it is greater than 0, then you get upward opening parabola. Therefore, condition I will write here. This is possible only when a is greater than 0 here. Is it correct? If a is greater than 0, you get upward opening parabola, or one more is called downward opening parabola or a downward parabola. Let me write x and this thing. This is x, x dash, y and y dash. This is called a downward opening parabola. The equation of this is y equals ax square plus bx plus c, and this is called downward parabola, also called downward opening parabola, because the mouth is opening downward, the mouth is upward. Here it is downward. What is the condition? When a is less than 0 here. A is the coefficient of x square. So there are 2 graphs over here. First of all, first you note it down, and then we'll go for geometrical interpretation of the roots. Where are the roots over here? Let us find out. First you must understand what is the graph that we get out of the quadratic equation. The graphs plotted against quadratic equations are called parabola. There are two types, downward opening and upward opening. Downward opening if a is 0 less than 0, and upward opening if a is greater than 0. What is a here? Coefficient of x square. So first you note it down, then we will go for geometrical interpretation. Okay, I hope you have noted down. Let me take up the geometrical meaning of the roots of this equation, quadratic equation, or quadratic polynomial rather than quadratic equation. See here, there are three cases. Again we are going to plot the graph of y equals ax square plus bx plus c. Case 1, the graphs what is case 1? I'll write later. Here you can see this is the parabola given to you. Here this parabola cuts the x-axis at 2 points. So these values are called the roots of the parabola here. So how many roots are there? There are two roots, one over here, one over here. Let the name of this root be alpha, the name of this root be beta here. For example, if it cuts at -4, then alpha equals -4. If this cuts at +5, then we say beta is equal to 5 over here. Alpha beta can be interchanged also. It does there is no order for this one basically. So this is the parabola, and which cuts the x-axis at 2 points, and therefore there are two roots. What are the roots here? Alpha and beta. Alpha and beta are the general notations for representation of the roots. Here the graph cuts x-axis at 2 points, and therefore there are two roots, alpha and beta. Is it very clear? Okay, now here I'll write graph cuts x-axis at 2 points. Graph cuts x-axis at 2 points. Therefore, number of roots or zeros is 2 here, and namely what are the roots? Alpha comma beta. Is it clear? One example I will try to demonstrate here. One example let us take. This is the example. This is the example. Suppose these are the two coordinates here. The point of intersection of this coordinate here, it is 2, 0, and the point of intersection here is 5, 0. Now can you tell me what are the roots of this graph now? X coordinate of point of intersection of the graph with x-axis is called the root here. So what is the x coordinate of this point of intersection? 2 here. Therefore I can write here alpha is equal to 2 and beta equals 5 here, because 2 is the point of intersection of the graph with x-axis and 5 is a point of intersection of the graph with x-axis. So always x coordinates are written first, next y coordinate. So 2 and 5 are here the roots of this equation. I hope you have understood. Next, case 2. Case 2. What we'll consider? The graph cuts the x-axis at single point. Let us take. Graph cuts x-axis at 1 point. If it cuts at 1 point, therefore number of zeros equals 1, namely either alpha or beta. Number of zeros 1, namely alpha or beta, only one. So let me write alpha here. So how do you get the graph here? at only one point. Can we get the graph something like this? This is the graph and this is the point of intersection, and therefore this point of intersection is root here, which is alpha. It can be either alpha or beta. Is it very clear for you? So one more point I will consider where there are no roots here. A small diagram I will try to plot here itself, and you should be able to understand. So let me take here itself. I think this part is visible. Maybe camera can be turned a little bit this side. So case 3 I demonstrate here. Case 3, first, second, and case 3. What is case 3 here? The graph does not cut x-axis at all. Graph does not cut x-axis at all. So in this case, number of zeros, nil, no zeros. How do we get the graph of this one? See, this is the graph of a quadratic polynomial. Here, is it intersecting here with the x-axis? There is no intersection at all, and therefore in this case, when the graph does not cut x-axis, number of zeros nil, no zeros, no zeros. So see here, from case 1 the graph can intersect at 2 points, therefore 2 zeros, namely alpha and beta, we can write it. And here graph cuts the x-axis at only one point. Here is the point of intersection, and this can be, we can name this as either alpha or beta, because there exists only one root, and here the graph does not cut x-axis at all, and therefore number of zeros, no zeros over here, and therefore for a quadratic polynomial we can have maximum of 2 zeros, no zeros, 1 zeros, and 2 zeros, isn't it? Therefore again here also maximum number of roots is equal to the degree of a given polynomial. Here the degree of the quadratic polynomial is 2, hence the number of roots maximum at most is 2. This is what you can, so you can note it down, all these things you note it down. Then we will go to the cubic polynomial. I hope you have noted down, okay? Now let us look at cubic polynomial, graphical meaning of zeros. Third one, linear we saw, quadratic we saw, now cubic polynomial. General form, degree 3, therefore number of zeros at most 3, at least 1 here. Very important. See here, the cubic polynomial, what about the graph here? There is no specific shape for a cubic polynomial graph, just like which we saw parabola and all. But thing is, here the graph cuts the x-axis at most at 3 points. Can it not at all cut? No, it is not. It will not happen like that. For example, let me take one simple cubic polynomial. Let us take y is equal to x cube. This is the simplest form of a polynomial, y equals x cube. So what will be the graph of y is equal to x cube? Let us see here. Graph of y equals p of x implies y equals ax cube plus bx square plus cx plus d. So case 1, here graph cuts x-axis at one point, graph cuts x-axis at one point. Which example? Let me take a very specific example here. P of x equals x cube here. So y is equal to x cube is the graph which we have to plot it. The graph of y is equal to x cube is something like this. This is the graph here. This is the graph of y is equal to x cube. Y is equal to x cube. Here it has to cut the x-axis at one point. Where it is cutting, it is passing through the origin. What is the x coordinate of origin? 0, and therefore 0 here is nothing but 0, or root here is 0 here. Are you able to understand? It is passing through the origin. What is the x coordinate of the origin? X coordinate of the origin is written as 0, 0. Is it right? Therefore in this case root is 0. Means I'll write like this. Root is 0 here. Root is 0. It doesn't mean that no zeros, or 0 is 0 here. X coordinate is 0. Therefore number of roots only one, and that is 0 here. So alpha equals 0. This is the answer here. Let me take another example. Second example here. Case 2. And let me write case 3 also here within this space. Case 2. Graph cuts x-axis at 2 points. Therefore number of zeros is 2, namely alpha and beta. Alpha and beta. So what will be the graph generally it looks like? This is how the graph looks like. Is it clear? This is the graph here. This is the graph of y equals ax cube plus bx square plus cx plus d. This is the graph here. Which are the point of intersections? This one and this one. And therefore this is alpha and this is beta here. Is it clear? There are two things. So for example, one example I'll take here. x dash, y and y dash, something like this. This is coordinate of this is -4, 0, and here it is 3, 0. So can you guess what are the roots of this equation now? This graph basically, what are the graphs of the roots of this polynomial? Or this graph? This is alpha here, this is beta. If I represent, this is alpha here and this is beta here. In this case alpha equals x coordinate of the point of intersection of the graph with x-axis. What is the x coordinate over here? -4. And beta equals 3, x coordinate of point of intersection. So here you have the case 2 where graph of the cubic polynomial intersects the x-axis at 2 points. Let me take one more case here, case 3. Graph cuts x-axis at 3 points. Graph cuts the x-axis at 3 points. Graph cuts x-axis at 3 points. 3 points. And therefore the number of roots will be 3 maximum, isn't it? Graph cuts x-axis at 3 points. Let me draw the graph. This is x, x dash, y and y dash. See here, is it cutting x-axis at 3 points? Yes, it is cutting x-axis at 3 points. Let me draw one more graph so that you can very clearly understand. Here it appears to be passing through origin, and this is alpha here, and this point is beta here, and this point is gamma here, gamma. So here you can see, you can tell me here, yeah, this is the graph here, which is cutting x-axis at 3 points, x dash, y and y dash. So here this is alpha, this is beta, and this is gamma here. So in cubic polynomial we can have only one root, we can have two roots, alpha and beta, and we can have three roots represented by alpha, beta and gamma. Therefore the number of roots over here is number of roots equals 3 here. And which are the roots here? Namely alpha, beta and gamma. Alpha, beta, gamma are the roots here. Important, alpha, beta and gamma are the roots over here. So remember, can you have a zero root over here? It is not possible. You must remember, one more question may come. Can we have a zero root? No roots. Zero root matlab kya hai? No roots for cubic polynomial. It is not possible, because the simplest equation here is y equals x cube, and if x is equal to 0, then the graph must pass through the origin here. And therefore if the graph has to pass through origin, the meaning the graph cuts the x-axis at origin, and therefore the value of the 0 is 0 here, isn't it? Not the value of the 0, the value of the root here is 0 here. Okay, I hope you are understanding. I think it is very clear over here. Please remember, for a quadratic polynomial you can have at most two zeros, namely alpha and beta. For a cubic polynomial you can have at most three zeros, namely alpha, beta and gamma. Okay, these are the Greek letters by which we denote the zeros or the roots. So I will write here one small statement at the end, which is the remark, which states that the number of zeros of a given polynomial, if polynomial is of degree n, at most the number of zeros of that polynomial will be equal to the degree of the polynomial. Number of zeros will be equal to at most the degree of the polynomial. Okay, so that one small remarks I will make it, and we'll then go to the next section. So it's a general remark. I hope you must have noted down. Otherwise you pause the video, go back, pause the video and note down. Okay, therefore one small remarks I will write with respect to the number of zeros. Remark: so it's important. This goes something like this. In general, for a given polynomial p of x of degree n, the graph of y equals p of x cuts the x-axis at most at n points, and therefore polynomial p of x of degree n has at most n zeros or roots. So this is what I'll say. So the remarks is, in general, a polynomial p of x of degree n cuts the x-axis at most at n points. Is it clear? In general, a polynomial p of x of degree n cuts the x-axis at most at how many points? N points. And therefore number of zeros or roots of a given polynomial number of zeros or roots of a given polynomial p of x of degree n, number of roots of a given polynomial of degree n equals at most n. Is it very clear? Number of zeros of p of x of degree n has at most n roots. Is it clear? Quadratic polynomial has 2 roots maximum, and cubic polynomial minimum 1 root, maximum 3 roots. So I think you have understood the concepts, whichever concepts I have discussed so far. In my next lecture, we will take up the relationship between coefficients and the roots. The relationship between the zeros or the roots and the coefficients of the polynomial. Okay, we'll end the session over here. See you next time. Thank you.